All right, good morning, lads, ladies, and lovers of algebra of all kind. Today is the last day before our first test. So we got a few special things planned for you today. First, there's an in-class activity, which we're going to do in the last 20 minutes of class, and I am going to set a timer on my phone to ensure that we get started on that with plenty of time to spare. Let me do that. And the other thing we're going to do is, of course, talk just a little bit more about quadratics, and we can take whatever sort of questions you guys would like to take from the homework set or elsewhere, any of the quizzes, and kind of use those as the basis for our review today. Finally, I am publishing a project for you, and that project is going to be due on the day of the test. So the project kind of serves as your own extra little review. Something that you can hand in to me and talk to me about in office hours if you like. So without further ado, let's get into the thing. If you have not done so, please do go ahead and download the attached file here, right? In the announcement that you followed to come to today's class, there is an attachment. That's the activity that we're going to do towards the end of class. Let's try one of the new pens. Well, here we go. This is MAC1105 section 015, which is college algebra. And today is the 1st of February, 2022. Just a little, well, so today we're going to review for exam 1 because, and an activity. Because, as discussed, exam 1 is Thursday. On the 3rd. And the test will take place during class. Now, I did want to say something. If you have any sort of accommodations through the DRC, anything like that, I do need you to reach out to me ASAP. So I haven't received any testing contracts from anybody in this class. So if normally, if there is somebody who has an accommodation through the DRC, I will get a letter or an email from the DRC saying, you know, so-and-so has these accommodations, please fill out this testing contract and make sure you do the following things for them. Haven't received anything like that. So if you have any sort of extra time or special environment or special tools or anything like that that you're entitled to, or you even think you may be entitled to, please go ahead and reach out to me. That way we can make sure that you're taking the test in the appropriate and fair environment. So if you have, or might be entitled to any testing accommodations, please Canvas message me. But just a reminder, the test is going to be in MyOpenMath. You will need to sign into a Zoom meeting on your phone, and then you'll be using HonorLock and MyOpenMath to take the test. So to take the test, what you're going to do is you're going to follow this HonorLock link here in Canvas. Right now, there isn't anything there, but when you click that link on Thursday, there will be a thing here that says exam 1. You'll click that link, it'll say launch proctoring. A separate window will pop up. You'll have to show it your ID. You'll have to scan around the room. Don't worry about Zoom on your phone. You may get flagged for having the phone there or for any noises that come out from Zoom, but I'm the one who manages and reviews those. So I will pay attention to any flags. If it's just coming from, our separate Zoom thing, then that's just fine. You don't need to worry about that. After you've cleared the unerlock like room scan and ID check, you'll follow a link that will take you over to MyOpenMath where you will see the test and you'll begin the test. After you finish the test, and this is very important. So as you solve the test, so I say on your paper, write full solutions, right? Show all your work. For the test problems. Once you submit the test, in MyOpenMath, immediately scan your work and upload the scan to Canvas in the assignment exam 1 written work. All right, so if you look in Canvas under the assignments, oh, I haven't published them for you yet. So you guys can't see this just yet, but you'll be able to click this link right here that says assignments, and there will be an assignment right here that says exam 1 written work. I'll show you what it looks like. All right, obviously you won't have these other things. You will just have something that looks like this, exam 1 written work. And you'll come in here and you'll upload the scan of your written work. So that is how I give you partial credit, right? And everybody wants partial credit. It's also really important for me to be able to give you guys good feedback, right? To be able to mark your work and be like, oh, here's where you made the mistake, or this is perfect. That's really good. Keep doing it like this. Any bit of information like that is really valuable to you guys. And it's, I take the time to do it. So I really want to be able to help you in that way. To make the scans, so a little further indent here, scans must be PDFs. I suggest one of the following: Cam Scanner or Adobe Scan or Microsoft Lens. I haven't actually used Microsoft Lens myself, but I had a student tell me it's very good. Or if on an iPhone, the Notes app. Notes actually has a little thing that allows you to scan. What I really don't want you to do, please don't just take a picture and try to upload that. That I'm going to set the assignment so that it has to be a PDF. And if you take a picture and just convert it to PDF, that's going to be really low quality. The contrast won't be adjusted right. The angles are often incorrect. But the apps like Cam Scanner and Adobe Scan work really, really well. So I won't show you now, but Cam Scanner and Adobe Scan I know are both free. They both work really well. They're both very easy to use. And you are required to upload the PDF of your written work. This is a necessary thing. It's not an optional thing. It is a necessary thing. You must upload your written work. Without the written work, not only will I not give you partial credit, I won't give you any credit. So big note here. Without the written work, I will not give any credit on the test questions. I need to see your work. It's very, very important. So these are the rules for the tests. All right, this is how it's going to be. Are there any questions or concerns? Anything like, I don't know if I can do that, or how do I do this, or anything like that? Okay. Now I will be with you on your phone through Zoom. So if you run into a problem or an issue during the test, of course, you can talk to me there. You need to stay in Zoom while you scan the work. You can operate any of these scanning apps with Zoom open. And only once you submit the scan of your written work can you leave the Zoom meeting. All right. So that's how the tests are going to work. It's not too bad, promise. Make sure you download these apps ahead of time, right? Make sure you've played with one of them at least and you know how to use it. Make sure you have Zoom installed on your phone already if you haven't yet. Make sure you have HonorLock installed on your browser, right? So the browser you have to use is Google Chrome. Make sure you have Chrome installed up to date. Make sure you have HonorLock installed in Chrome. Last call for questions on the test. Anything else? Okay, very good. So I wanted to review just a few key concepts, and I want to open the floor for you guys to ask review questions. So if you could, go ahead and pull up My Open Math in your browser and scan through these homeworks and quizzes to see what was giving you a hard time, and then type into chat whatever problems you want to see. Like you can type quiz 1, problem 5, something like this. Let me know. You want to see. And in the meantime, I'm going to lay out some key concepts for the test. Of course, real numbers and interval notation are a big deal. The definition of a function. And this includes things like domain and range. Then we have increasing and decreasing functions. Mins and maxes. And these are both things, remember, increasing and decreasing always give me intervals of x values, open intervals of x values. And for mins and maxes, remember, if I ask you where is the min, I'm asking for the input or the x or t value, whatever that independent variable is. If I ask you what is the min or what is the max, I'm asking for the output or the dependent variable, the y value. Oh, sorry, that was 3. We had a full study of linear functions. So under here we have things like slope-intercept form. That's the y equals mx plus b. We have that point slope form. But y minus y0 equals m times x minus x0. We have the concepts of parallel and perpendicular lines. Remember, two lines are parallel if they have the same slopes. And two lines are perpendicular if they have opposite reciprocal slopes. Also, we have vertical and horizontal lines. I'll say horizontal and vertical lines. A horizontal line is like y equals a constant. A vertical line will always have the equation x is equal to a constant. And then, of course, linear regression. So you need to be comfortable sketching the graph of a linear function. You need to be comfortable figuring out if a table describes or does not describe a linear function. You need to be comfortable giving me or graphing from the slope-intercept form, giving me or graphing from the point-slope form, and then these extra little details. We talked about rates of change. This includes the average rate of change, which was the slope. And also talking about units of measurement. Then absolute value functions, where you need to be comfortable graphing, solving equations, and inequalities. I'm going to continue listing things, but I do see some stuff in chat here, folks asking just questions. Okay, we will get to those in just one second. The last big topic that we had, of course, was quadratic functions. And here you need to be comfortable with the standard or expanded form. Squared plus bx plus c, the vertex form, which is a times x minus h squared plus k. All the normal graphing things, right? So graphing from both of these. Solving equations. By factoring. Using square roots. Or the quadratic formula. What else did we have in here? Anything? Oh yeah, we talked about, I'll just say applications. Like the cannonball. There's a problem like that in our activity today we'll talk about. And then complex numbers. So I'll say the discriminant. Was that b squared minus 4ac thing, which tells you how many and what types of roots you have. And complex numbers. So that is a pretty thorough list of the stuff that we could see on the test, the topics we have covered so far. I'm going to go ahead and just start digging into the questions that came to me in the chat. Looks like a handful of folks want to see homework 7, number 25. So we'll start there. Okay, so give the standard form of the quadratic function who has the x-intercepts 5, -8, and goes through the point 4, -324. All right. It's homework 7, number 25. With x intercepts 5 and -8, and passing through -4, 324. Okay, this is actually a fun problem, and it has to do with thinking about factoring. So you know one way to find x-intercepts is to factor your quadratic, right? So we know that x-intercepts are related to factors. If x equals 5 is an x-intercept, another word for x-intercept is root, right? Then x minus 5, is a brand new pen, must be a factor, right? The factored form of this quadratic, when you factor it, if x equals 5 is one of the x-intercepts, then one of those factors must be x minus 5, because when you set this equal to 0, you get x equals 5. Similarly, since x equals, -8, sorry. X equals -8 is a root. X minus -8, which is the same as x plus 8, is a factor. Okay. So then the factored form of this quadratic, I suppose I should add under here, there are forms, right? Factoring, let's add it like this, and factored form. You can think of this as an extra form of the quadratic if you want. When we talk about higher order polynomials, we will definitely talk about the factored form as a special thing. So in addition to the standard form and vertex form, you can think of any quadratic as being expressible in this factored form, where R1 and R2 are the roots or x-intercepts, and A is that lead coefficient, same number that you would have in any of the other two forms. So this tells us that my quadratic, let's call it f of x, is a times x minus 5 times x plus 8. I don't know what the lead coefficient is yet. I don't know what this number a is yet, but I know that since 5 is a root, the factored form must have an x minus 5. Since -8 is a root, the factored form must have an x plus 8. And then the only thing left to do is to figure out this number a. Can anybody tell me what bit of information that they gave us will allow us to find the number a?
Plug in y and x from the other coordinate.
Exactly. They gave me a point that's on the graph. They told me that -4, -324 is a point on the graph, which means when you plug in -4, this function, the output y or f of x, is going to be equal to -324. So now, to find a, we set f of -4 equal to -324. So f of -4, well, that's what you get when you plug in -4 for x. So that's a times -4 minus 5 times -4 plus 8. And this thing, f of -4, I know is -324. So that's equal to a times, let's say, -4 minus 5, that's -9. -4 plus 8, that's +4. Oh, and I should open Wabbit, right? So 9 times 4 is 36, right? And then I've got a. So the left-hand side is still -324. And the right-hand side is a times -9 times 4, which is -36a. So finally, to finish things up, all I have to do is solve for a here, and I can do that by dividing both sides by this -36. So I'll take my -324 and divide by -36, and I get 9. So f of x, I know it's a times x minus 5 times x plus 8. And now I know what a is. A is 9. So it's 9 times x minus 5 times x plus 8. And that's your final answer. These are good problems. They really are. And like I said, later when we talk about higher order polynomials, you'll see a lot of problems like this, where I give you some roots and one other bit of information, maybe the y-intercept or some other point that's on the graph. You use the roots to write down the factors, and then you use that extra bit of information, whatever else is given to you, to find the lead coefficient.
So if it's on the test, would we have to, that answer would be accepted, or would we have to factor out or distribute the 9?
Let's see.
Or-
So what did they ask for here? I suppose I should be careful. They want the standard form. So if I just said, give me the quadratic, this would be good. Sorry. So they want standard form. So we have to FOIL it out. The 9 will have to distribute, but before I can distribute the 9, I need to FOIL these two factors. So x times x is x squared. And then I'll have plus 8x from my outers, minus 5x from my inners, and then 5 times 8 is -40. So this would be 9 times x squared plus 8x minus 5x is plus 3x minus 40. So that's 9x squared. 9 times 3 is 27 plus 27x. And then 4 times 9 is 36. So 40 times 9 is 360. So yeah, this would be your final answer as the problem was written. So if I just told you, find me the equation or expression for this quadratic, I would take either one of these. If it said, find me the expression for this quadratic in standard form, then I would need it like this. So a good catch there, Tyson. Thank you. Any other questions on this guy? Okay, let's move to the next problem that was requested then. So I think the first two requests were both for that problem. Next was homework 6, 28, and 29. Okay. Patient has an illness that typically lasts 24 hours. Temperature T in degrees Fahrenheit of the patient T hours after the illness begins is this. Use your calculator to graph the function, answer the following questions, round all to one decimal place. And then, okay, yeah, we can do both of these. They're sufficiently different. I'm not going to write all the words down here, but I will get the important stuff down. So the temperature function, capital T of little t, is negative 0.029 times t squared plus 0.7076 t plus 97.4. And they say we want to graph the function on the calculator. We want to answer when is the temp highest. And we want to know what is the max temp. Okay. So here's our question. Just boiling down the pertinent information. They also told us that this illness usually lasts only 24 hours. That will be useful as we try to pick our Windows settings in the calculator. So the very first thing we'll do is turn it on, go to y equals, clear out anything that is there, and type in this function. So that's negative 0.029. I'll have to use the variable x squared plus 0.7076x plus 97.4. And if I hit graph right now, I don't know what my Windows settings are like in this. Probably we won't see anything. And that's because my Windows settings are incorrect. So looking at this function, if you plug in t equals 0, these terms both go away. So the y-intercept is really big. It's 97.4. So I need to make sure my y-axis is at least that tall. And we expect the temperature to go up at first. So we're going to pick our Windows settings to have a y max of something bigger than 97.4, but still reasonable for a range of temperatures. Let's put the y max at 120. If this person's temp goes over 120, they're fucking dead. The other thing, we were told that the disease usually lasts about 24 hours. So let me make 25 my x max to make sure we're at least getting the 24 hours in there that we need, and just see what we get with this. Okay, I can see part of the graph. Maybe my vertex is somewhere around here. Just to embiggen the picture a little bit, right? Because it's still kind of tough to see. Let me increase my x scales a little bit. Let's go from negative 50 to 50. There we go. That's a pretty solid picture of this graph, right? Now, what I really want, I want to know the max temperature, which is going to be the y value at this vertex. And it's hard to say exactly what it is using the trace function. I can estimate here. I see that it looks like the tallest this thing ever gets is around 101, but 101 point what? We can guess using this. So let me just add a little note here. From the graph, the vertex h comma k appears to be somewhere around 13.8 comma 101.6, something like that. But that's just a really rough estimate. Remember, the trace function will not give you exact values. So to answer these two questions in detail, like correctly, we need to do the mathematics. So for part B, what am I looking for? When I want to know
Vertex.
when, Yeah, go ahead, sorry.
The vertex,
Which part of the
The-
vertex?
the H,
Yeah, so for this, we need H, and for this, we need K, right? When is the temp highest? Well, that's asking when or where is the max, right? So that's the input or X value at the vertex. What is the max temp? That's going to be the output or the Y value of the vertex. So for part B, we need H, which we remember is always negative B over 2A. So that's the negative of 0.7076 divided by 2 times negative 0.029. And this is arithmetic best done by the calculator. So I'll take negative 0.7076 and divide that by, now watch what I do, pay careful attention to this. You've got two things downstairs here. If I were to just type 2 times negative 0.029, would this give me the correct answer? It looks just like I have it written here.
Would it give you an error?
It wouldn't give me an error, but the important thing to remember about the calculator is it's fucking dumb. The calculator doesn't know that you want to divide this whole number by this whole number. When you type this, as it's been typed here, what it's going to do is take negative 0.7076, divide that by 2, and then multiply the result of that division by negative 0.029. And that's not what I want. I want it to divide this number by 2 times that number. In other words, I need to put the downstairs in parentheses. So divide by 2 times negative 0.029. And then close. So always put, when you're putting stuff into the calculator, always put the top and bottom of your fraction, if there's more than one part, in parentheses, the whole thing in parentheses. So you see I have the whole downstairs here in parentheses. That's because the calculator does order of operations exactly as you were taught in grade school. Multiplication and division just done straight left to right. So it wouldn't divide by 2 times that number. It would divide by 2 and then multiply upstairs by that negative 0.029. And that's not what we want. So here's what we get, 12.2. Had we done it the other way, just for fun, negative 0.7076 divided by 2 times like this, negative 0.029, you get something very different, right? So those parentheses, they make a big difference. This first parentheses and the very last parentheses tells me that the 2 and the negative 0.029 are both downstairs. Without that outer parentheses, it's going to put the negative 0.029 upstairs, even though it looks like it's downstairs. Okay. So what is this being measured in? What are the units here? Hours, right? And if you think about the number, hours is what makes sense. This being minutes for a 24-hour disease wouldn't make sense. The disease normally lasts 24 hours. Makes sense that the fever would peak midway through, not minutes into the thing. Okay, the other thing we want is K. And to do that, we're going to plug H into our function. So our function, remember, is called capital T. So I'm writing K equals T of this number H we just found. And this is more calculator stuff. I'll write it out. Negative 0.029 times 12.2 squared plus 0.7076 times 12.2 plus 97.4. And then again, just be careful entering into your calculator. Negative 0.029 times parentheses 12.2 squared plus 0.7076 times parentheses 12.2 plus 97.4. Blammo, 101.72. At the second decimal place there. And this would be degrees. Degrees Fahrenheit. So we can check and see how good our approximation was. When we looked using the trace function, it looked like that max temp would be hit around 13.8 hours. That was off by quite a bit, right? It was really 12.2 hours. The max temp, the Y value appeared to be 101.6. We were pretty damn close with that. That was not bad, but the trace function is not perfect. It's useful for getting you an idea, but it's not perfect. The actual max is, here's the closest we can get to it with the trace. Okay. Any questions about this guy? All right, let's go ahead and knock out number 28 there. So this is our rectangle. One side of a rectangle, or sorry, 29 is the next one. One side of a rectangle is 6 centimeters longer than 3 times the other side. Find the lengths of the sides given that the area is 360 centimeters squared. Is 6 centimeters longer than 3 times the other side. The area is 360 centimeters squared. Find the side lengths. A picture can be helpful with this sort of stuff. They tell us one side is 6 centimeters longer than 3 times the other side. So I'll just draw myself a little rectangle here. It doesn't necessarily have to fit the proportions of the problem. Call one side X. Then the other side length, this side length, I'm going to describe in terms of X according to what they told me in the first sentence. So this side is 6 centimeters longer than 3 times the other side. So that means this side is 3x plus 6, right? 6 centimeters larger than 3 times the other side, and the other side is x. They also told me that the area is 360. I'm leaving units off. That's okay here. We can set up a quadratic equation from this information because you know that the area of a rectangle is always its length times its height, right? Or length times width, whatever you want to call these things. So we get that x times 3x plus 6 must be 360. Oh, I'll switch to purple here. Sorry, we're solving on me. So this is the quadratic equation I need to solve. And the trick here, we're going to multiply everything out, pull it all over to one side, and then see what we have. So distributing the x, I get 3x squared plus 6x equals 360. But I cannot solve a quadratic equation in this form, right? It has both x squareds and x's, so I can't solve it using square roots, which means I need to subtract this over and either factor or use the quadratic formula. So I'll subtract 360 from both sides, getting 3x squared plus 6x minus 360 equals 0. And you could just plug straight into the quadratic formula if you want to. You could start trying to factor this as it is if you want to, but I'll tell you what I see. I see a factor of 3 in the first term, a factor of 3 in the second term, 6 is 3 times 2, and a factor of 3 in the last term. 360 is 36 times 10. You know, 36 is divisible by 3. So let's bring out the 3, and I'll get x squared plus 2x minus, oh, there's my timer. We'll switch over in just a second. 360 divided by 3 if we're not sure. I don't mind checking this stuff. 360 divided by 3. 120? Yeah, 120 equals 0. And then we can ask ourselves, does this factor, can I come up with two numbers that multiply to negative 120 and add up to positive 2? And I think 10 and 12 will work. Right, so if you look at negative 120 and start writing down factors, like you could write this as, well, let's see, 12 times 10 is the first one that comes to mind, but you could also do 6 times 20, 3 times 40, right? All of those with positive and negative signs appropriately chosen. We want them to add up to positive 2. So if I take the 12 to be positive and the 10 to be negative, that will work. Which means this quadratic can be factored as x plus 12 times x minus 10. So setting each factor equal to 0, x is either negative 12 or x is equal to positive 10. Side lengths cannot be negative. So I cross this guy out and I get that x is equal to 10. That's one of my side lengths. The other side length, if this guy is 10, must be 3 times 10 plus 6. Which is 36. So those are your lengths, 10 and 36. Okay, it is time for us to pivot now over to the activity. So I'm going to assign everybody into breakout rooms. Make sure you have your activity downloaded, saved, printed if possible, somewhere you can look at it. Just start working through the problems. The first problem, I give you a quadratic. I want you to put it into vertex form. So remember the way you do this. You find h using the formula, then you plug h in for x to find k. Once you have your quadratic in vertex form, I want you to sketch a graph of it for me. It doesn't have to be perfect, but make sure you label the vertex and one other point clearly. Doesn't matter what other point you use. So put into vertex form, sketch the graph, then tell me the range. Second problem, a book is being thrown off the roof of building A at Santa Fe. That roof is 32 feet above the ground. The height of the book t seconds after I throw it is given by this function, negative 16t squared plus 12t plus 32. I want you to tell me, when does the book reach its max height? What is the max height of the book? And when does the book hit the ground? To find the max height and when, these parts A and B, you're looking for the vertex. Part C, you're trying to find when the height is 0. That's when the book hits the ground. So you'll set this thing equal to 0. I recommend the quadratic formula, but if you want, you can factor out a common factor here first, just like we did in that last problem. Last problem here, I give you another quadratic, x squared minus x minus 6. I want you to calculate the discriminant, that b squared minus 4ac thing, and tell me, based on the discriminant, how many roots, x-intercepts, and of what type? Do we have 2 real roots, 1 real root? Oh, this is the code, you don't need the code. 2 real roots, 1 real root, or 2 non-real complex roots. Then factor the thing. Then sketch the graph. And you can use the factored form to sketch the graph. Just sketch the x-intercepts. And based on the lead coefficient, you know if the graph, the parabola opens up or down. So tell me a decent sketch of the graph there. It doesn't have to be perfect, but make sure you label the x-intercepts and have the graph opening up or down. All right, we're gonna put you guys into breakout rooms. I'll give you some time to work. I'll bounce around the rooms. Let's assign automatically. We have 24 folks here. So let's do, yeah, that's fine. All righty. Go ahead and join your breakout room. I suggest assigning one problem to each person or each pair of people, something like that. Okay. Who are we missing? Cole, Carly, you guys there? All right, let's start checking in on folks. Hey guys, just wanted to drop in real quick, see if there's anything that we wanted help with.
No, sir, I think we're good.
Alrighty. Again, I recommend assigning like a problem to different folks, you know, let folks work on different things so we can move through it. I'll come back through in a little bit and ask you guys a few questions about these.
Thank you.
Yes, sir.
Sorry about that, it mutes me automatically. Anything we would like to ask about?
Not yet.
Okay, I recommend assigning a problem to, you know, a person. Don't everybody work on the same thing at once. And I'll come through and ask you in a few minutes some questions about these that you'll want to be ready to answer to get credit. So make sure you work the problems. Make sure everybody has a reasonable understanding of what's going on. And if anybody's having a hard time with anything, don't hesitate to talk to each other or talk to me. Hey guys, how's it going?
Hey, I had a question about number 1.
Yeah, what's up?
So I know that to start, you have to find the vertex, which I found, plug it in, and then you solve for x, right? Or you can factor it or put in the Pythagorean's theorem to solve for x.
So there are things you could do. Like if you wanted to find the x-intercepts, you could use the quadratic formula, but you don't actually need that. So to sketch a graph, once you've found your vertex, all you really need to sketch a reasonable graph is any other point on the graph. So I would say after you find your vertex, go ahead and find like the y-intercept or something, and then just use those points. Use the vertex and the y-intercept to graph your function. Does that make sense?
And you do that by setting it equal to 0, right?
No, setting equal to 0 will find you the x-intercepts. If you want the y-intercept, you can plug in 0 for x. But
Yeah. Okay, yeah, that's fine.
cool. Okay. Anything else you guys would like to talk about? All right.
And for number B,
Yeah, go ahead. What was the question there, Tyson? I think it cut out. Maybe we're having some technical difficulties. I'm going to bounce to one of the other rooms, but then I'll come back to see what that question was in just a second. All right, while Tyson's working on number 1, I would recommend Macy and Lexus take a look at one of the other problems. Hey guys, how's it going?
Hey,
Hey, how's it coming along?
I think some of them were still working on it, so I moved on to problem 2.
That's fine. Yeah, I think it's probably good to split it up. So, one person work on problem 1, another person work on problem 2, another on problem 3. Something like that is a good idea. Is there anything that anybody would like help with or like to talk about? I think probably the breakout room chat I can't see all of. Lexi, I see you saying that you got 3 and -8. Was that for the vertex of the first problem? I'm sorry, what was that? Oh, I see. I'm sorry, I wasn't looking at the chat just now. Yeah, 3, -8 is correct. Oh, and I just realized that graph doesn't quite have room for you to get all the way down to -8. You can just extend that down a little bit if you need to there, or kind of put it where you think it would be, the 3, and then you can move your vertex down and just label that as -8.
Yeah, that's what I did. I got the range as -8 affinity.
That's correct. Yeah, -8 to
Okay.
infinity. And you want to think about whether there should be a bracket or a parenthesis.
Yes, sir.
on -8.
Yeah, there's a bracket on -8.
Okay. I've got someone in another room asking for some help, so I'm going to bounce over to them, but I'll come back to check on you guys in just a little bit. Hey, Justin, there's a question.
I'm sorry, I couldn't hear you because the meeting thingy popped up right whenever you started talking.
Oh, I'm sorry. I got flagged that somebody in this room had a question. I wasn't sure who it was. Maybe.
Oh, I'm sorry, that was me. I wasn't able to find the attachment, but I found it by going through Canvas now. It wasn't on my email.
Yeah, it's going to be in the Canvas announcement. Yeah. Are the problems coming along okay? Is there anything you guys would like to ask about those? Okay, I got one other room I need to check up on, then I'll come back through and ask you guys some questions.
Okay.
Hey guys, how's it going?
Hi,
Hey,
we're just working on problem 2. We just finished problem 1.
Very nice. Is there anything you'd like some help with or anything that you guys wanted to talk about?
I don't think so. Samantha, did you have anything you wanted to talk about?
no, I think we're good.
Doing good so far? How about you, Catherine?
I think her mic is like acting up because she sent something.
Can
in
you,
the
ca-
chat.
yeah, can you hear me?
Yeah, I can hear you okay.
Okay, no, I'm good.
Doing good? All right, cool.
Yeah, thank you.
Okay. I'll come back through in a little bit again.
Okay.
Thank you.
All righty, gang, just coming back through to check up and see how things are going. Anything that we're stuck on or like to talk about? Any questions, anything like that?
Could we maybe do number 2?
Yeah, is there a particular part of problem 2 that is a little sticky?
Yeah, B, just finding the maximum height.
So we've already found the time then, right? We found the part A we're comfortable with.
Partially comfortable with it.
Okay, let me turn on a screen share here and we can kind of talk through it together. So when does the book reach its max height? That's going to be the input for the vertex, which is h. So here, let me write down the function. H of t is negative 16t squared plus 12t plus 32. All right. So if I want to know when does the thing reach its max height, that's the negative b over 2a stuff, right? That's the t value or the input for the vertex. So that would be negative, and then b is 12 divided by 2 times negative 16. And when we compute this, we want to be careful. Remember what I said about the calculator when you're dividing, make sure you put the whole bottom in parentheses. So this would be negative 12 divided by parentheses 2 times negative 16, close, like this. I get 0.375. So the book is going to reach its max height 0.375 seconds after it is thrown. Is that what you guys got?
Yes.
Beautiful. All right, so then for part B, to get K, we're going to plug this number in here. So that's negative 16 times 0.375 squared plus 12 times 0.375 plus 32. And again, we'll put this in the calculator, just being kind of careful. Negative 16 times parentheses 0.375 close square, then plus 12 times parentheses 0.375 close, and then plus 32. And I get 34.25. So the book doesn't make it up very far, right? It only goes up by 2¼ feet from the original height, but then it's going to fall back down. Do you guys feel comfortable with part C? Are there any questions about how we're going to find when the book hits the ground? I could graph the thing. Let's go 40. So here is my parabola. If I really want to focus on the part I'm interested in, I could change that x min to like -1, the x max to like 7, or let's go with 5 for now and see what we're looking at. There we go. So the book goes up, 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 and then it falls, 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 falls. And if I want to guess at that time, I can use my trace function. Oh, where is that guy? He's way off to the side over here. There he is. So we found the max height already, right? That max height, we got 0.375 and 34.25, and that's about this guy. And the time, we can scoot over here when it hits the ground. That's when this thing comes back down to 0. It looks like it's going to be around 1.8 seconds. But if I want to know for sure, I need to set this thing equal to 0 and solve. So for part C, we need to solve negative 16t squared plus 12t plus 32 equals 0. And since everything here is divisible by 4, I would probably pull out a 4 to make my numbers smaller. 32 divided by 4 is what? That's my brain. 32, well, when in doubt. 8. Good Lord. Now, you could try to factor this thing, But my suggestion is to just go ahead and use the quadratic formula because these are real world numbers. This -16 is acceleration due to gravity. This is the initial velocity. So this problem is not designed to make this factor. So I would go ahead and plug this into the quadratic formula. Pulling the 4 out just makes your numbers a little smaller and easier to work with. Does that feel comfy, cozy?
Yeah, thank you.
Sure.
Thank you.
Yeah. Alrighty, gang, welcome back. Zoom forces a 1-minute timer for the breakout rooms to close. So I'm going to keep us here for just 25 more seconds while we wait for everybody to come back. And then we will talk about some of these problems, not all of them. Mm-hmm. 2, 1. There we go. All right. So now we are all back together here in the main session. Thank you guys for working on these together. Let me just share with you a little bit about how to solve some of these. I want to start with problem 2. So for problem 2, this is what a nice, neat solution would look like. The height of your book, given t seconds after it is thrown, is this function. In part A, we wanted to know when does the book reach its max height? And remember, when or where does the max occur? That's always the input here. So we're looking for the x coordinate, or we call the t coordinate of the vertex. So if the vertex is h comma k, we're looking for h. And that's always negative b over 2a. So that's the negative of 12 divided by 2 times negative 16. And you need to be careful with the calculator as you enter this, the way I described earlier, putting the whole downstairs in parentheses. You should get 0.375, and this is in seconds. So about 1/3 of a second after the thing is thrown, it reached its max height. What is the max height? Well, that's asking for the y value of the vertex, so the thing we call k. So to find k, remember, you just plug the x value of the vertex h into the function. So everywhere there's a t here, I substitute in the number we found in step A. Simplifying, we get 34.25 or 34.25 feet. For the last part, we want to know when does this book hit the ground. My advice is to factor out a 4. Each of these numbers is divisible by 4. So what we need to do is set the height function equal to 0. All right, that's when the book hits the ground. It's when the height is 0. So we're going to take this thing, set it equal to 0, and our first step there would be to factor out this 4. From there, we'd use the quadratic formula. Which will give us -3 plus or minus the square root of 3 squared, which is 9, minus 4 times a, which is -4 times c, which is 8, all divided by 2 times -4. So I'm applying the quadratic formula to this piece. And again, if we put this in our calculator, just being very careful. Oh, it closed the calculator. I want to get you guys out of here on time. So you plug this into your calculator and you will get out your answer. Real quick, before we go, problem 1.
That would be the positive answer, right?
Yes, certainly the positive answer. Yeah, good mention there. We're going to get 2 answers out of this. One would be positive and one would be negative. We want to take the positive answer here because we're talking about time since the book was thrown. The first problem, we want to put this thing into vertex form. And we're given x squared minus 6x plus 1. And then sketch a graph. I didn't realize as I was typing this up that I didn't give you enough vertical space here on the y-axis to get to your vertex. So if you couldn't graph it exactly, if you had to just label the point down there, that's okay. But to find the vertex, again, h is negative b over 2a, which is negative 6 divided by 2 times 1, which is just 6 over 2, which is 3. K is going to be f of that thing. So we're going to plug that number in, which is 3 squared minus 6 times 3 plus 1, which is 9 minus 18 plus 1, which is negative 8. The other thing we know, that number a, the lead coefficient is 1, which is positive. So the parabola opens up. And just this information is enough to get a pretty good graph. I mark this as 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7, 8. My vertex is down here. If I want one other point, so my vertex is 3, negative 8, said we want to label the vertex and one other point explicitly. Another point that's always easy to get is the y-intercept. You don't have to use that, but you can. And this comes from plugging in x equals 0. So we look at f of 0, which would be 0 squared minus 6 times 0 plus 1, which is positive 1. So your y-intercept is right up here, the point 0, 1. And that is enough to draw a very nice looking parabola. Like so. The last problem, I just asked you to factor a quadratic. I'm pretty sure we can all do that. But if you had any difficulty with the discussion of the discriminant or figuring out what kind of roots you have or coming up with the factored form or sketching the graph here, please don't hesitate to come talk to me in office hours. I have an office hour immediately after this, and I would be happy to work through that or any other problems you guys have there. I'll just say really quickly, if I know the factored form of this thing, this was x squared minus x minus 6. I can factor that by looking for two numbers that multiply to -6 and add up to -1. That would be -3 and +2. And then setting each of these to 0, you get 3 and -2 for your x-intercepts. So I come out here 1, 2, 3, 1, 2, and I can plot those 2 points. 3, 0, and -2, 0. You could find the vertex by taking the average of those two, right? Remember the vertex, the x-intercepts are always symmetric about the vertex, but you don't need to do that. You could take as your extra point the y-intercept, which is -6. 1, 2, 3, 4, 5, 6. That is not our vertex. but it is another point on the graph. Your vertex is actually like right here. And just knowing the x-intercepts and that this parabola opens up is enough to get a pretty good graph. And once you have one other point on there, that would be acceptable, even if that point is not the vertex. So here, the vertex, we don't know that yet. But that's okay. We still have a pretty good graph. Right? I would accept this as long as you have these 3 points or any 3 points labeled, or the vertex and one other point. So I'll leave it at that. I know everybody's anxious to get out of here. If you want to talk more about these or any other problems, come see me in office hours, send me a message on Canvas. You know the deal. Test is on Thursday. So make sure you're watching Canvas. Make sure you sign into that Zoom meeting from your phone on time, early a little bit if you can. That way we can get everything set up and get everybody rolling nice and smooth. If you have any questions about exam procedures, if you need anything from me, any exam accommodations, please send me a Canvas message. We'll get that stuff sorted out. Otherwise, I'll see you on Thursday for the test. All right.
Can I take a screenshot of number 2 real quick?
Sure.
Another question. So the test review thing, that's going to be on math, my math lab, right? Or
Review thing, just trying to think about, so there is an exam review up in my open math. And that guy, I think, has been open for some time. Here is number 2. A solution for number 2. Really quick before we leave, let me make sure that that exam review is available for you guys. So the practice quiz. I'm going to tab over to MOM real quick.
It's there.
It's there? Okay, good. Yeah, so the exam review is there in my open math, and it's set to be on Thursday.
Can you show number 2? I'm sorry. All I see is your face.
Oh, yeah, here, number 2.
Thank you. I'm sorry.
No, let me sorry. Yeah, here's the solution for number 2.
Thank you.
You're welcome. And the exam review is right in here, test 1 review quiz, and that's not set to be due until Thursday. So there's nothing else that you guys need to work on between now and then, besides the project that I'm going to post here to Canvas. So watch Canvas for an announcement about the little project. That is the test review we talked about at the start of class. And then the review quiz in my open math is here. Maybe that was the confusion. There's kind of 2 different review things. There's the review quiz in my open math, and then there's the written review, which is the project that I'm going to publish for you in Canvas. Alrighty, gang, that's it. I will see you guys on Thursday for the exam. Again, if you do have any questions about what you need to do, come visit me in office hours, and I'll be happy to work with you there. Alexis, maybe send me a Canvas message. We might be able to work something out an alternate time. All right, just stay in contact with me, Alexis. We can talk. If you can't come to office hours, send me an email or Canvas message. We'll figure something out. All right, take care, gang.